Now we're going to move into Chapter 19, which talks about the magnetic field and how a single charge behaves when it's moving in a magnetic field. So what are magnets? Well, magnets you probably have used since you were a kid. They basically create a magnetic force, what we call permanent magnets. And these permanent magnets have two poles. They're called north and south. And like poles repel each other and unlike poles attract each other. So that's similar to electric charges. So here you can see magnets levitating due to the magnetic force, that some are stuck together and some are levitating due to the repulsive forces in between like poles. So magnetic poles cannot be isolated. In a charge, we can have a positive charge or a negative charge, and we can isolate one from the other. However, we cannot isolate a single north or south pole. If we cut a magnet in half, we repeatedly get a north and a south pole. If we cut it in half, we get a north and a south pole again. We keep cutting it in half, and we always have a north and a south pole. We can never get to the point where we just have a north pole or just have a south pole. There are some physicists that are working on trying to see if we could ever isolate a monopole, but from what you'll see where magnetic fields come from, I doubt if that is ever possible. So there are different types of magnetic materials. What you call a magnet typically has iron in it. But there are soft magnetic materials such as iron that are easily magnetizable. They also tend to lose their magnetism pretty easily, that you can have iron that is not magnetic. Iron that itself is not a magnet, but can be magnetized. Hard magnetic materials are cobalt and nickel are difficult to magnetize, and they tend to retain their magnetism for much longer. So what causes magnetism is basically the spin and movement of electrons. So in chemistry class, you probably learned about the spin of an electron, and that's what we call the magnetic moment. It's either pointing up or pointing down. And when all those magnetic moments line up, then we get a material that is itself magnetic. So there are different types of magnetic materials. Again, there's many different types. The iron, the ferromagnetic that we typically talk about, are iron, cobalt, and nickel. These are the things that we can actually make magnets out of. But we can also magnetize other materials so that they are affected by the magnetic field, even water. And so some of the other common types of magnetism are paramagnetic, where we have all the regions line up for ferromagnetic, but not so much for paramagnetic. These are the hardest to magnetize. Antiferromagnetic is we actually get some going up and some going down. And ferrimagnetic, such as this chemical, are up, a little bit up and a little bit down. So we get magnetic properties with unpaired electrons. It's non-magnetic or diamagnet magnetic if their electrons are all paired up. So not surprisingly, this falls on the periodic table, that we have our ferromagnetic compounds down here by iron. Antiferromagnetic is chromium up here. And paramagnetic, so materials that are magnetizable with the right conditions, are all the white ones, including oxygen. So water is one of those ones that we can get to be magnetic. And diamagnetic are in here that we really have a hard time magnetizing. So what are the sources of magnetic field? Well, throughout this chapter we're going to go through all the sources. So far we've talked about a bar magnet. Next we're going to talk about the Earth. But in the later parts of this chapter we're going to talk about these other sources of magnetic fields and being able to make an electromagnet. Now that we've talked about that there are different types of magnetic materials and different ways materials respond to a magnet, what would you say to the statement that all metals will respond to a magnet? So this means if I move a metal close to a magnet, will the metal move and be attracted or repelled by the magnet? And so does that hold for all metals or only a few? So true or false? The answer is false. Not all metals even will respond to a magnet. There are some that are very difficult to magnetize, and you can see here in the picture that only a few look like they're attracted to the magnet. Iron, nickel, and cobalt are the only ones that themselves will just react to a magnet. Now, can we magnetize the other ones, and will the other ones respond in a magnetic field under the right conditions? But generally not. So aluminum just generally will not. So if you go try to a magnet on your soda can, it's not going to respond. If you try it on your lead pencil, that's not going to respond. If you try it on a titanium implant, it's not going to respond. On your copper pipes in your walls, that is also not going to respond. To your tin foil that you use to wrap things in when you cook them in the oven, is not going to respond. So this links to, the image links to the full video if you want to watch him going through and testing all these materials and seeing if they are magnetic. But again, only a few of them actually do stick to a magnet.